EtherChannel. So far we have discussed in the spanning tree that one of the port goes, if you have redundant links are good, but they can create a problem. But the spanning tree resolves the problem. But how the spanning tree resolves the problem? It makes sure that only if you have even 4 paths available, out of 4 paths, only one path will be available. So even though you have connected four links, for example, I can just show you 1 minute. Let's say I have these 4 switches, and in these 4 switches, I have these 24 with connected with 24, 23 with connected with 23. Okay, 24, 22 is connected to 22, for example. Okay, 21 is connected to 21. So even though you have 4 links between these switches, so tell me how many interfaces will be up and how many interfaces will be down or in the blocking mode. Because of the spanning tree, only one port will be open. Only one way will be open. If you go into the switches, you can see you see this is because this is the root port. That's why it's all of the 4 ports are goes down up actually, but you goes on this other switch. So you can see other switch actually. This switch has how many ports are blocked. Basically, you have 4 ports, 1 block, 2nd block, 3rd block. Only one path is available to open. Rest of the 4 ports are down. So with the spanning tree, the problem is, yes, it resolves the problem at layer 2, but it creates the problem that you have 4 links. These 4 links are cable. Maybe if they're fiber link, they're a very expensive link between the 4 ports. Now the problem is, yes, if one link goes down, the other would take over and so on. But the other problem is that the link, you have 4 links. So each of them had 100 megabits. Each of 100 megabits can be combined into the, what we can do if we can only use one link, because 100 megabits is only available, even though the full speed, the full capacity is actually 400 megabits. So in order to use all these linked together, we can use a combination called port channel. With the port channel, we can do what we can do is we can achieve we can combine all these resources, all the ports together in a one logical port. What we achieve is we achieve redundancy, we achieve our throughput increase from 100 megabits to 400 megabit, and also we will trick the spanning tree as well, because spanning tree will see only one port. The thing is, if we have 2 switches and if you have only one port available or one path available, then what will happen that if this port will always stays up because there is only one port. Sorry, I think it's wrong. Okay, this one. So this port will be staying up all the time. So how we can create a port channel? So to combine them, maximum we can combine 8 ports: gigabit, fast Ethernet, Ethernet, fast Ethernet, 10 gigabit, 100 gigabits. So you can combine them up to 8 ports. So how we can do this? My interface range will be F. So we can use interface range command 21, 22, 23, 24. And I'm saying shut. So when you configure the port channel, make sure the interfaces are shut on both sides. Interface range command, which we want to same configuration for on all these ports. Okay, so these are ports are shut. Let's say I'm going to this switch. The command will be channel group 1. This could be a number of like any local number, mode on, and the other side will be on as well. On. So now you see what will happen. Are you verified your EtherChannel summary? SU mean layer 2 in use. So you will see now they will become one port. Okay, they all combine and they will give you the speed up to 400 gig, 400 megabits. You can see all the ports are up now. You see, show EtherChannel summary, show IP interface brief. So you see the port channel here is up. Show interface port channel 1. So now you can see in the spanning tree point of view, you can only see one port. You're not seeing as a 4 port. If you see them as a 4 ports, then you block all the 3 ports and open only one port. Now because only see the port 1, that is why it is in the, and the cost is look at the 7. So basically with the port channel, you not only get the redundancy, but increase the number of trick the spanning tree. It shows the spanning tree just one port. Then the other problem it resolve, it give you the more bandwidth as well. All the links combine into the logical way and then give you one link. Okay, so that's called a port channel. Now the port channel has 2 modes. One is configure. When you say very simple configuration, show run. We how many ports we have? So we have 21, 22, 23, 4. All these ports are combined logically into one port now. So you see only we have given one channel group mode on command. What we can do is we can give the range 21 channel group 1 mode. So there are different modes actually. On mean you are ether channel. Active, and passive. This exchange the LAC-P protocol, which is used on all the other switches as well. PAC-P is only between Cisco and Cisco. Okay, so one side can be LAC-P, active, command is rejected. You see, I remove them from the channel group. Active, okay, you see one side is on, another side is active. So sometimes you need to shut and unshut the ports. if any misconfiguration is happening. You see, I mean standalone now. Okay, they are suspended. So you see the reason is because one side is active and the other side is actually on. So active passive use LAC-P and auto desirable use the PAG-P. These are the two protocols used Cisco to Cisco. Okay, so this is the ether channel.